Welcome back to the channel. So today we will be discussing the last problem of today's weekly contest, longest path with different adjacent characters. So we are given a tree with n nodes and we have to find the longest path in the tree such that no pair of adjacent nodes have same character assigned to them. So every node in the tree has a character assigned to it and we have to find the longest path in the tree such that in that path, no two adjacent nodes have same character assigned to it. So let's understand this with an example. So let's say this is the tree is given to us containing these 7 nodes 0 to 6, and these are the characters assigned to every node. So 0, like A is assigned to the 0th character, 0th node, A is assigned to the second node, and so on. Now let's say you have to find the path, right? Longest path. So let's say you take this path. This is one of the path, right? uh, so let's say you take this path. Now if you take this path, this is not a valid path because you can see 2 and 0 has same character to them. So there are two adjacent nodes which have same character assigned to them. But in the given question, we have given that no pair of adjacent node have same character assigned to them. So this is not a valid path. Now we can take another path, maybe this. So again, this is not a valid path because you can see 1 and 4 has same character assigned to it. So valid path will be something like this. This is a valid path because you can see A and E are adjacent only and they don't have same character. So similarly, this is another valid path. Similarly, this is another valid path. So what you have to do is you have to find the valid path. You have to find the longest valid path such that, and the valid path is defined by no pair of adjacent node have same character assigned to it. So hope the question is clear. So in this case, in this particular case, this will be the answer. So answer will be 3. Like we can't find any valid path greater than length 3 which have like which are valid. So basically in this case answer is 3. Now how to solve it? So currently you can see there are a lot of paths, right? Like you can see this is one of the path. We have seen another path which is which can be something like this. There can be another path which can be starting from here and going till here. So there are a lot of paths here. So as I always keep on saying, let's before solve, like if original problem is little bit harder, try to solve a simpler version of the problem first. So instead of path, what if I told you to find the longest single straight line? So let's say this is 0 to 5 is a straight line, 0 6 is a straight line. So in that case, this 203 201 will not come because 201 is not in a straight line. So basically what I am trying to say, let's, instead of solving this problem, let's try to solve the problem with straight lines. So let's do this for this particular case. So we are only solving for straight lines, only solving for the straight lines in the question. So we are trying to find the maximum or the largest straight line for each node, or let's say in the entirety, whatever it is. So we are not considering any path which goes like this or that. So those are kind of excluded. So how to solve this? Now first thing is you have to find the straight line, right? So straight line, let's say you start from 0. So straight line could be anything starting from here to one of its node, right? Either you will go down this, and once you go down this, you can't, you don't care about other paths like 2 and 1, you don't care about. And once you go down this, you will again try to find the longest path from here, right? And once you go down here, you will again try to find the longest path from here, and so on and so forth. So basically what you are trying to do is you are just trying to repeat the problem. Like you are trying to break the problem into sub problem which is of same, which is exactly of the same kind. So in this case, what we are saying is we need to find the longest path starting from 0, right? So instead of like what we are saying, let's take longest path will be starting from 0, will be in one of the children, right? Either here or here or here, right? So we are saying let's try to find the longest path for each one of them, and then we will take the max of all the three, and that will give us the longest path for current node. So when we are trying to find the longest path of node 0, we will try to find the longest path of node 6, node 2, and node 1, and maximum of all this will give us the longest path from 0. But there is a catch. We haven't taken care of the condition wherein we are saying that we have been given that no two adjacent nodes should have the same character assigned to it. So when we are trying to find the longest path for 6, 2, and 1, we will only take the longest path of 1, because we already know that 0 has a assigned to it. So we can't take any children which have a assigned to it, right? So that's where we will only consider the children which don't have the current value assigned to them, while considering the longest path for the current node. We can find the longest path for each one of them that is required, but while considering the longest path of 0, we will only consider the longest path for 1, because that's the only node which have different character assigned to which a different character assigned to it than 0. And so hope this part is clear. Now let's try to actually solve it. Like let's say that we need to find the longest path for each one of the node. So if we are trying to find the longest path from 0, we will say let's try to find the longest path from 6. So once we are trying to find the by saying this, we have basically reduced our problem set to this part of the tree. And problem is again similar. We have to find the longest path starting from root. So longest straight path starting from 6. So now we will again say that 6 longest path from 6 will be from anywhere from 7. So we will take 7, and now the problem will be now the problem is reduced to finding the longest path from 7 in this particular tree. So hope you are getting the intuition that there is a recursion involved here. Okay, so now once we have seen that recursion involved here, what is the base case? Base case is when we reach the uh, bottom, the leaf of the tree. So the longest path from 12 will be 1, because only 12 is there, nothing else is there. So now let's try to find the value for each one of them one by one. So let's say we have to find the longest path from 0. Okay, so for that we first go to 6 and try to find the longest path from 6. No, we notice that these two have equal character, but still we will try to find the longest path for 6, because that is required. Like we have to find the longest path for each one of the node. So that's where we are going to uh, we are going to find the longest path from 6. But while considering the longest path of 0, we will not consider it. We will see in a moment. So basically, we for longest path of 0, we first go here, find the longest path for 6. For longest path of 6, we go there, find the longest path from 7. From longest path of 7, we go there, longest path from 11. For 11, we go here, longest path from 12, and that's the leaf. So longest path from 12 is 1. Okay, now longest path from 11. Now for longest path of 11, we will consider the child of 11 which don't have the same character. So here C 11 has C and 12 has B. They don't have same character. So 12 can be considered while considering the longest path from 11. So longest path from 11 will be longest path from 12 plus 1, right? So that is one candidate. So here only one child is there, so that's the maximum. Otherwise, if there are multiple child, we will try to take the maximum over all this. So answer for this would be 2. The longest path from 11 will be 2. Now let's start for let's we have to, like, again we will go back, like we are doing a DFS, right? So we will go back to 7. Now once we go back to 7, we will try to find the longest path from 8, the next child of 7. So here again the answer will be 1, because it is a leaf node. Then we will go for 9, answer will be 1, because it is a leaf node. We will go for 10, answer will be 1, because it is a leaf node. Now for 7, we will try to find the longest path. Now remember, 7 we will only consider while considering the longest path while calculating the longest path for 7, we will only consider the childs which don't have the same value as 7. So in our case, 7 has value e, so we will only consider the children's which don't have value e. So in this case, no one has value e. So we can consider any one of them. So if we decide to go to 10, what will be the longest path from 7? It will be 2, right? So that's the one candidate, because from 10 the longest path is 1. So if we include 7 here as well, so longest path will be 2, including 7. So similarly, if we consider while like longest path will be going from 9, in that case the value will again be 2. So max of 2 and 2 is 2 only, or let's write that 2 as well. So now we'll consider longest path from 8. Again, 8 and 7 doesn't have the same character, so we can consider 8. While considering 8, we will see that longest path from 8 is 1. So longest path starting from 7 will be 2. Now we will consider 11. Again, we can see C and E. 11 and 7 are not same character, so we can consider 11. Longest path from 11 is 2. So longest path from 7 would be 3. Okay, so these are the sets valid. Like, these are the valid sets, or maybe like these are the candidates for the longest path from 7. We will take the maximum. So longest path for 7 from 7 will be 3. Okay, now let's for 6 again we will try to find the longest path. So in here the longest path is 4. Okay, because 6 and 7 doesn't have same character, so that's where the longest path will be 4. Now for we will go with 1, so go with 0. For 0 we'll first try to find the value of 2. For 2 we'll try to find the value of 1. 5 is a leaf, so longest path will be 1. For 2 the value will be 2, because there is one child 5 which doesn't have the same value a and d, so they are not same, so we can consider 5. So that's where the longest path is 2. Now for 0 we will again go for 1. For 1 we will go for 3. So for 3 the longest path is 1. It's a leaf node. For 4 the longest path is 1. It's a leaf node. Now for B we have only one candidate. Like notice that we can go here, but because 1 and 4 have same character, we can't consider 4 while considering the longest path from 1. So we'll consider 3, and 3 we like from 3 we'll get 2. So that's the longest path from for B. For A, now let's see, like for A, see we have 4 here. If we consider 4, the longest path will be 5, but we can't consider 4 because 0 and 6 have same character assigned to them. Now for this, the answer, like if we go with 2, like longest path from 2, the answer will be 3. But again, we can't consider 2 because 2 and 0 have same character assigned to it. Now we have no other choice than 1, and we can see 1 has different character, so then the answer will be 3. Longest path from A will be 3. So hope you get this point. So by this exercise we have done, what we have found is longest path from each node. Okay, now once we have solved this, now we have to solve the original question. Remember, the original question says we can have non-straight line paths as well. So currently we have only considered straight line paths. That's why we have considered only one child, but there can be path like this, right? And there can be path like this. So we have to consider all those things. Now let's again try to think about it. So what when we are saying that we have to find the longest path from uh, longest non-straight line path, then we will basically we can have this kind of path, right? So notice that for a path we can only go to two of its child, right? So we a path can't be like this. A path can't have this entire nodes, because this is not a path. Either this will be a path or this will be a path, right? So it can't have both. So basically what we are now seeing that for a path can be formed from two straight paths. So we have one path here and we have another path here. So a non-straight path can be formed only by merging these two straight paths. There is no other path that we can take. So what we have like what where we are coming is non-straight path is a combination of two straight paths, right? At max two straight paths. There can be one straight path as well. That is also a path. So now what we will do is we will try to find the combination of two straight paths in the same question. So let's again come here. So now you can see, uh, so here we have to find non-straight paths. So non-straight, like for seven, let's try from 12. So for 12, there is nothing, like for leaf node there is nothing. So that's the only path. For 11, uh, there is no two children, like 11 doesn't have two or more children, so there is no path from 11 to its two children, so that's not possible. For 7 has more than one children, so there can be like these kind of paths possible, right? So that's where, like, now how to, like, why, like, which two we will take, like whether we took, we have to take two, right? Like we have already said that the non-straight path is a combination of only two straight paths, at max two straight paths. So either, like, which two to take, like which two child, to take 11 or 8, or we should take 8 or 9, or we should take 9 or 10, or we should take 10 or 11. So which two child we should take? Remember, we can't take all of them. Basically, like if 7 has 4 child, but we can't, we can only take the child which don't have the same value as 7. So the path will be something like some nodes here, and then 7, and then some nodes there, right? So this is a child of 7, and this is again a child of 7. So these two should not be equals to the character of 7, right? So if character of 7 is 8, these two can't be a. So basically we have to consider the candidates again which don't have the same character as 7. So we have already find such candidates, so these are the these are the 4 candidates. Now we have to take 2 of them, right? And we have to find the longest path. So let's just sort it and take the last 2. So that will give us the longest 2 straight lines from 7, and the final answer will be, like this 2 includes 7 as well, right? These 2 include 7 as well. So 7 is included twice, like in this 2 as well and this 3 as well. So that's where we will just minus subtract 1 while considering the longest non-straight path. So longest non-straight path for 7 would be 4, because we have the candidate list, and with this candidate list we just sort it and take the last 2. And once we take the last 2, we already know that last 2 has 7 included. So both of them have 7 included, but 7 can be included only once. So basically the first will have this and second will have this, just for example. So 7 is included twice, so that's why we are subtracting 1. So we have 3 plus 2 5, and we are subtracting 1 and get 4. So 4 is the non-straight path, longest non-straight path that will be crossing from 7. Similarly, let's find for 6. So 6 doesn't have more than one children, so it doesn't apply here. Let's go for 0. Before 0, let's go for 2 and 5. This 2 doesn't apply here because this have one children. 3 and 4 doesn't apply because this doesn't have any children. For 1, it applies because it has two children. But unfortunately, here the two children have different values. See, like, we have already said that, like here 1 is there, right? And whatever comes left to the 1 and whatever comes right to the 1 should not have the same character as 1. So here 1 has b, so whatever we choose should not have b here. So we can't choose 4 because 4 has b. So that's where only one candidate is there, c. So despite of the fact that b, like 1 has two children, it doesn't have longest, it can't have the crossway path because uh, actual candidates while considering the crossway path is 1. So b also doesn't apply. Now for 0, again the same question, same thing. For 0 we have three children. We can take 6 2 6 1 or 1 2, but again we have to consider about this condition, right? Whatever we choose should not have the value of 0. So character assigned to 0 is a, 6 is also a, 2 is also a, so these two goes out of scope, and we have only one. So we, despite having three children, actually we can consider only one children. So because we don't have two children, so that's where the longest path, there will be no crossway path. So here again there will be no crossway path from 0. So hope the question is clear. So basically what we have to do is, first, sorry, so what we have to do is, for each node, find the longest path first, okay, and then again traverse, like, for crossway path, like for this kind of path, try to find the list of all children which doesn't have or rather which doesn't have the same character as the parent, and from all this list of children, just take the maximum 2, and that will be considered while considering the longest path from 7, longest crossway path from 7. So hope this approach is clear. Let's look at the code. So the code is very simple. First, what we have done is we have just like we have these two path, crossing path and longest path, as we have discussed. One is the longest path, straight path. This is a straight path, uh, the straight path basically, and this is a crossing path which is combination of two straight paths. Okay, now basically what we have, like what we are doing here is, we initially everything we initialized to 0 and everything. So then we can just build the entire graph, like we are given a parent, we give the entire graph. Now once we have entire graph, I am just calling DFS. In this DFS, I am calculating both the longest path as well as the crossway path. And once we have this longest and crossing path, the answer will be just max of both for each node. Okay. So hope this part is clear. Now let's look at the DFS function. So DFS function is also very straightforward. For each node, initially every node has longest path of length 1, that node itself, that's it. So that initially I assign it to 1. Now for each child I am calling the DFS. Basically I am calculating for each child longest path of itself, of that child, and crossing path from that child. So that DFS will take care. Once we calculate everything for the child, we are seeing whether the character of child is equals to the current character or not. If it is, this child is of no use for calculating the value for myself, basically the SRC. So just continue. Otherwise, just for longest path, like see, current denotes the longest path. So for longest path, just take the maximum of the child longest path plus 1. Plus 1 is for current node. And as we have discussed, we have to build this candidate list as well, right? So that we can sort it and get the largest 2 while calculating the cross paths. So that's where I am building the candidate list. Notice that we have already skipped all those child which doesn't have the which have the same character. So after this, all will contain all the candidate list for the current node. So I am just sorting it, and after sorting it, checking whether the candidate list has more than one element. Basically, more than one child should be there. Child candidate should be there. We have seen that if number of child is 3, like here 0 has 3 childs, but yet the candidate list is single, like only one. So that's where we are seeing the candidate list, and crossing path will be just the last 2 plus 1. Like this last 2 doesn't, like here in our example, we are in longest path, we have considered 7 as well, but here this all, I am not pushing longest path plus 1. See, like plus 1 is not there. So that's where instead of subtracting 1, we are just adding 1, because current node is not there at all in neither in this or nor in that. So hope this entire approach is clear. If you have any doubts in this question, please link them in the comment below. I will answer them definitely. And if you want me to point out some mistakes in your code, if you have solved with the same approach, feel free to comment that as well. I will definitely revert back. I have been solving these kind of questions and the follow-ups of several kind of interview experiences from Leetcode. So if you haven't checked them out, please do check them out in the description below. If you like the video, give it a like and do subscribe to the channel. I will see you tomorrow. Thank you.